All right, hello everyone, and welcome. This is our second session for week one, and we've got a number of topics to discuss today. This time we will be getting into the basic building blocks of a music system for a game. We'll be talking about different approaches in building a soundtrack in a way that can change and interact with the action that's going on screen. We'll start from the idea of a blank DAW session and determine how we might build our tracks and build our composition, starting from scratch and creating something that, when by the time we get to the end of the full piece, that it will be composed and formatted and bounced in such a way that it can be put back together by the computer and made to interact and vary according to whatever the player, whatever actions the player chooses. So we will start from the very basic components and work our way up to a bit more of the complexity of how this might work in a game. And so the first half of this month is mainly focused more towards the creative side of, again, how you might start from nothing, how do you determine what music you might need, where does it all go, and how you might build your compositions. And then later on in the month, we will get into more of the technology and tools and workflow that is involved in getting your music actually working in the game. How does your music interact with the gameplay, with the graphics, with the code and all of the technical aspects working behind the scenes to make it all work, because it's a lot of moving parts of which your music and sound are components of the overall machine that's putting the full game together. So, building the music for the game, what components do we have? What tools do we have to start building our music and building it in such a way that it's going to make sense when it all plays back in the game? We could just write linear music. We could just write music that has a standard structure of a beginning, a middle, and an end, and just like a music album, have different individual tracks and individual songs play back to back. But there wouldn't be any reaction or interactivity from the music while you are playing the game. If all of the music was predetermined and had no possibility for ever changing over the course of gameplay, then there would be no interactivity, there would be no direct tie between the game that's going on screen and the music that the player hears. So, when we are talking about music for a game, we are not. We are talking about a dynamic music. We are talking about music that changes over time and reacts to the players' interactions. They push buttons on a controller, or they use a mouse and a keyboard on their computers, and they are playing the game. It's a constant feedback loop. The game starts, and the graphics are drawn on screen, and the player hits buttons on their controller in reaction to what they see on the screen. And then the game reacts to the buttons that are hit on the controller, and it draws new graphics on the screen, and it constantly goes around and around. The game reacts to the player, and the player reacts to the game. And so then if your music was just a static piece of music that never changed, then you would not be part of that sort of feedback loop. It would just kind of be playing separate on the side, as if you just had a music player, iTunes, or music streaming service just playing in the background while you play the game. And we want more direct connectivity or direct interaction between our music and the gameplay. So we are talking about dynamic music that changes over time. The opposite of that would be static music that doesn't change or interact or conform to whatever else is happening in the game. So in order to make music switch and change, we have to build our soundtrack in a series of pieces and parts and little chunks of music. Instead of a full composition, or instead of a 2-hour-long single soundtrack like you hear behind a movie, our music is built in little files that are changing and switching over time. As you may start to experience as you are working with this first project, a 2D platformer, you see that the music is delivered in a series of 9 files, and those files will randomly play according to whatever is happening in the game. And so since our music is divided out into little chunks, some of those chunks play once and some of them repeat over and over and over again. And the idea of a music loop is very important in our game soundtrack, because it allows us to musically stay in one spot while the player figures out the game, while they solve the puzzle, while they search for the secret treasure. Whatever the action is, it allows us to sit there and wait for the change in the action before we progress on into the new musical idea. And using these loops, we want to avoid repetition. We don't want to annoy the player. We don't really want them to even be aware that they are in a loop. We kind of want them to be lost in the music. They don't know when it starts and stops, but they know, or subconsciously, it is changing in the background, maybe even with them, with the player being aware of it, without the player being aware of it. So a linear loop, extremely important in our music soundtrack, where the idea of a loop is that as the music reaches the end of the file, it has to be able to immediately jump back to the top and start over again without any interruptions to the rhythm, the melody, the mix, the overall production. You don't want anything to identify that the music has started over, so no pops or glitches. And as I mentioned before, you want to lose them musically in the composition, so no real obvious markers or signposts that say, okay, 1, 2, 3, here we go, we're going to start the music all over again. Now, in 2D platformer, you are using a series of 8-bar loops, and I do not want you to leave the class or leave going through these projects with the understanding that all games are made up of 8-bar loops or 4 or 16-bar loops, or really small musical phrases that over hours of gameplay are constantly changing and switching around. You have, in a much longer game experience, you have a lot more time to develop musically, where instead of being confined to an 8-bar phrase, we have minutes worth of music cues that take their time to explore key changes and tempo changes, all the while making sure that wherever you wander off to in that piece of music, you always come back to that original point so that you can loop back around and start back up again. So longer pieces that can loop and go around and around if necessary, but you can't do that forever. And it depends on how invisible your music is, how much of it's a direct piece of music that sits in the front and has a strong melody. If your music is highly catchy and very memorable, then it might be more obvious as that music comes around that you have, oh, here's part A and here's part B. As we switch between them, they become really obvious because the player hears them so many times as they go around. So a lot of games have what's known as a board switch, which is okay, the music is about to get boring and repetitive. Let's go ahead and switch it off. The music, you have a 3 minute long piece of music. It goes around once, loops and plays again, maybe comes around a third time, but before you hit that fourth time, before you've made the decision that this music is going to get repetitive and annoying, you might fade it out, a slow fade out to silence, or it doesn't even fade when music fades to silence. But at that point, the player would hear sound effects. They would hear ambiances, maybe the players running around the game world, so they hear footsteps and breathing. But the music isn't there to annoy somebody. And this is a creative choice and a constant choice of how long you can keep this music playing before it really starts annoying somebody. And that's very much up to individual taste. And a lot of times you can distract the player with the rest of the game so that they're not really focused on the music. But here in the chat, so using a hook is not that great of an idea. It all depends on the context and where the music is, like in cutscenes, where or more story-driven elements. Then maybe the music is there just like a film, like sitting right alongside the action and following it up and down with the emotional ups and downs through the storyline. But during gameplay, where you have less of an idea if they're just going to get lost and wander around, maybe bringing something that's really hooky or really obvious or really cool at one point might get too repetitive as it keeps going around. So often music during gameplay is much more subtle, much more underscore than direct than you might find during other parts of the game. So with the board switch, Nintendo games were always really good at this. If you left the controller sitting around too long or you didn't do all that much, Link would like bring out a book and start reading in Legend of Zelda, and Mario would just like go to sleep. So there was that aspect of, okay, you're just sitting around doing nothing. But there was also, okay, this gameplay is taking too long, so we're just going to kind of fade everything out, go to just sound effects while they're figuring it out, and then they turn the corner, they find the next part of the story, and the music swells back in like it should have been there the entire time. So you have a looping assignment in week 1 that goes over a number of different approaches to looping. And you will utilize those different looping techniques for all of your compositions as needed, as you more than likely as you create your compositions and start having to create your music as looping files. Then you'll start needing these different techniques because they'll a lot of times it'll just cut off the end of a file as it loops around. It feels like all of your instrumentation just stopped and restarted. So different techniques for actually creating seamless invisible loops are really key, and it all depends on how the music is composed. So the other thing that I definitely want to get across is that often music isn't even composed with the intention of it looping when you first compose it. Meaning that in the beginning, while you are creating music, while the game is being developed, especially in the early stages, there isn't much of a game to compose for yet. There aren't set levels or worlds or characters or locations or plot points or objectives. A lot of that stuff comes over time, and if you wait till the very end when all of that stuff is created to actually start writing your music, then a lot of times you're very much behind. So while the game is being developed, you are creating pieces of music for ideas and context and story and emotion. I have 12 main characters in my game, and I have 20 worlds or levels or areas, and I have a basic like 2 hour long storyline that I'm trying to follow, and I might start writing music for danger and action and suspense and stealth and emotion and character and world and level, like really big generic ideas that can start narrowing down the music and the sound palette of this game to say, okay, what is it? What type of music are we going to do? What sort of instrumentation are we going to use? How big is this composition going to be? Can we start writing musical themes that fulfill different parts of our story? And you create and compose music in a linear format, just like you would create a composition for. And a lot of this is just ideas and kind of propositions of how this might work. But it is something that everybody can listen to and look at and go, okay, this is going to work here and this is going to work later on in the game. And as those parts of the game start to exist and they finished levels 1, 2, and 3, and they've created the home world or level for this character, and all of those parts will start coming into you. Then you can go back to your kind of repertoire of music for this game and start picking out themes and ideas that you go back into the session and start cutting out loops and okay, this part of the game is this long and we need this much of action music for this part of the game, and you start taking chunks out of your music and conforming them to the necessary parts of the game. And so you often take linear compositions and edit them and change them so that they loop properly for different parts of the game. So a couple of different techniques that definitely help your music to make it function as a loop. Number one, if you actually compose your music knowing that it's going to be a loop, and you write 4 bars at a consistent tempo that is structured as a loop, then it's going to be nice and easy because that's what it was intended for. But if you then have to edit and pull something from a linear composition, it becomes more difficult. So your choice of instrumentation is important. Faster, more staccato instruments with sharper attacks are easier to loop. Low bass and choirs and big pads and things that sustain and have a lot of, that are just big and powerful, are more difficult to loop. Fades, sometimes you can get away with fades, meaning that you fade off into some other idea before you loop back and come back around. What this does not mean fade to silence. You should not fade to silence, or else there will be a little pop or gap, or maybe even a really noticeable gap in the music as it fades to silence and comes back. But fading here means kind of coming down from the peak of the composition, taking some of the instruments down and away, moving into an element that's easier to loop, and then bringing back whatever you had. Basically, anything that is added to the music file should be taken away before it comes back around. Or else it's going to build and build and build and build, and then it stops and starts over and jumps back to square one and builds and builds and builds. So anything you add has to be subtracted before it loops back around. Rhythmic material is a whole lot easier to loop. Drum loops are a lot easier than string sections to loop. Because of, again, the sharp attacks, the highly rhythmic divisions of the music allow for easier loops. Sometimes you can get away with effects where you throw the music out into big reverbs or delays or wild kind of mixtures of effects where the music kind of disappears into all sorts of weird effects and then comes back again. DJs do this a lot as they try to go from one record to another, where they'll have one tempo and they'll crossfade into just a whole bunch of reverb and delays and reverses and all sorts of stuff that kind of loses the rhythm, and then they'll move into something else at another tempo. So if you need to get back to where you were, you might kind of break the music apart before it returns back to where it was. And the last one is editing. We talked about a couple of different editing techniques at the end of last session, specifically focused on the looping assignment, whether you are bouncing MIDI and kind of doubling the amount of, doubling the length of all of your bounced files and cutting them in half and only using the second half. We discussed that approach in part 2 of the looping assignment. And part 3 talks about chopping a file in half and flipping the two sides and crossfading the middle and creating other types of loops. So there's all sorts of different approaches to creating a looping piece of music. And loops become a very integral foundation for a music system. And you are constantly transitioning between pieces of music that loop and ones that don't loop. And that's what we'll talk about next. A one-shot is a piece of music that does not loop. It only plays once. So you need to disarm the bomb. And so for the next minute, you have bomb disarming music. And you know that once that timer's up, the music has to stop. You're either going to disarm the bomb at some point or not. And that only exists in that period of time. Or you get a power-up. And for the next 30 seconds, you go into berserk mode. And so 30-second long music cue for berserk music has to play during that time. And then when the power-up is over, then it returns back to whatever piece of music you heard. So it could be a musical one-shot. We also talk about stingers. All stingers are one-shots, but not all one-shots are stingers, if that makes any sense. Meaning that stingers are one-shots in that they only play once. But not all one-shots are stingers. Stingers are meant to add emphasis or embellishment, to kind of point out something that you did that is either good or bad. If you find the secret, or you find the power-up, or you solved the puzzle, or you got more health or armor or something like that. Sometimes you hear a little flourish of notes. If you did something good, it's often in a major key and it kind of goes up in an upward direction. If you did something bad, it's often in a minor key and goes in a downward direction. To really give you a musical hint that, okay, that's good, do that some more. Or, hey, next time you probably want to avoid that action because you heard this negative music. Here is our adventurer in the temple, and there is exploration music as the hero explores the temple. They find a secret, or they find a little bit of treasure, so a found it stinger plays. And sometimes it stops the previous piece of music, like it kind of pauses it real quick while it plays this little musical phrase and crossfades back into it. Or maybe they're meant to play together, where the stinger is not so it's not so obvious, or not so what's the word I'm looking for? Not so infiltrating. It just kind of it doesn't step all over the previous piece of music. So you want to make sure that, again, keeping it maybe in key helps so that it doesn't clash with the previous or the constant playing music. So it's there to draw attention, to say, to kind of comment or respond to whatever you've just done on the screen. It can be musical, or it can be sound effects. Sometimes stingers are used as sound effects. Think about ghost voices in a haunted house, where every few seconds you want a spooky ghost voice to kind of play through the game world. Well, you don't want to record 10 spooky ghost voices and have it play back the exact same way each time, or they would just hear the loop go around and around and they'd hear the same voice every single time. But instead, you could chop up those 10 ghost voices into individual files and have the game randomly play them in different parts of the world. Like if you have a big room and you want the ghost voice to kind of move at different points in the room and travel around, you can have it randomly start from different points. You can randomly change the pitch and the volume and even low pass filter of how these sounds are played back. So if you have a lot of like really random sounds, drips in a cave, or a dog barking in a neighborhood, or birds tweeting, where you don't want to have the same bird in the same tree tweet the same way over and over and over again. That's certainly not natural, but you can have stingers, or use the idea of stingers, of sounds that randomly play according to whatever is happening in the game world. So puzzles, power-ups, secrets, environments, these are really common uses for stingers that react to whatever just happened, whatever action just took place on screen. Our next idea here will discuss how our music actually knows how to switch and change. Like what happens in the game that actually tells our music to go from intros to main loops to ending. How does it know when to change? We know when it's supposed to change, right? We talked at length in our previous session about 2D platformer, and we said that we really are focused on the idea of intros, main loops, and endings, where when the game starts, there's 3 intros. It randomly chooses one of those intros, plays through that. When it reaches the end, it can randomly choose a main loop cue, plays through those endlessly, and eventually when you run out of health, when you the player loses a life, then it's going to immediately switch over to the ending cues. So conceptually, we understand how it's supposed to work, but how does the game know how that's all supposed to work? And the real quick answer to that is some programmer somewhere programmed the game and coded it and told it to do it that way. But we're going to take a look at it from the standpoint of the music, as in what is happening behind the scenes that allows our music to switch and change. So I'm going to take a quick pause here. Before I jump into this topic, please let me know if you have any questions, and I'll be right back in about a minute or so. Okay, so game states. I have a very bad definition for game states. And my English teacher always told me never to use the words that I am trying to define in the definition. So here is my very poor definition of game states. A game state is the state the game is in at any one time. It is what is happening at any moment in time, at any frame of the graphics on screen, at any millisecond in time. How does what is happening in the game at any one moment, and can we use that to determine how our music is going to switch and change? So we will take a kind of a tangent here for just a moment to talk about the idea of frame rates in a game and we'll tie that into how the game itself knows how to work with our music. So hopefully at some point you have probably discussed frame rates in a previous class. More than likely it might have been like a post-production or audio type class. And just to quickly refresh, or if you haven't heard of the concept of frame rates before, your frame rate is how quickly an image can be put to the screen. And this comes or originates from film, where film was divided out into individual pictures that were moved across the camera at a particular speed, and that would display the image on screen. And if you did it fast enough, then it would seem like moving, or it would seem like motion on the movie screen. And so film, the frame rate of film, the movies roll by at 24 frames per second. At 24 times in 1 second, an image is placed on the movie screen. And as these go by at a particular rate, then we perceive them as motion on the screen. And so the frame rate of movies or film is 24 frames per second. The frame rate of television, black and white television, is 30 frames per second. So then when they started going to broadcast TV, the United States standard for alternating current out of the wall, your power connection out of the wall is 60 cycles, right? So your plug gets 60 cycles AC electricity current flowing out of the wall. And at 60 hertz, they were able to draw 2 images on the screen. They basically drew half the image, every other line on the screen, at 60 times per second. So that meant that you got a full image every 30th of a second. So 30 times a second, broadcast television, black and white television, was drawing an image on the screen. So then when broadcast television went to color TV for video engineering and broadcast reasons, they had to slow down the frame rate to add in the color information. And so you might be familiar with a frame rate known as 29.97, which is a way of counting the images drawn on the screen, which is pretty darn close to 30 frames per second. And if you've ever had to do any sort of time code math, you certainly understand how fun 29.97 frame rate becomes. So that is film and television. And it's commonly considered that around 30 frames per second we consider to be smooth animation or smooth motion on a screen or a film, like a film screen. So now we switch over to games. Games aren't limited by the 60 cycle power that's coming out of the wall. They are limited to how fast the computer processor runs and the graphics processor runs in order to draw an image on the screen. So you maybe, if you play games, you often run into discussions of frame rate, of the quicker the game can draw an image on the screen, the higher the frame rate, and the smoother the animation, the better the game looks overall. And games have often strived for 30 frames per second to portray smooth animation. And nowadays, with the PlayStation 4 and the Xbox One, they advertise frame rates of 60 frames per second, where the computer is drawing an image on the screen 60 times for every single second that goes by. And that means that the game is figuring everything out about the image, the gameplay, the physics, the networking, the music, every aspect of what is happening in between those frames. The game only runs as quick as the frame rate, because if it went any faster than what it can draw on the screen, it would be unfair. It would be doing stuff that you couldn't actually see. It would basically be getting ahead of what it could actually draw on the screen, which would be completely unfair. And so the game only moves as fast as the images can be drawn on the screen. So that means that at 60 times per second, or let's go down, let's even do 30 times per second, because that's more common. Even now, it's still quite common. And if you play PC games or Mac games, you know that there is no set standard, and it can often get way lower than that, than 30 frames per second. It gets down to 20 or 15 or 10, and anywhere below that, the game gets real sluggish, and it skips frames, and it gets all jaggy and jumps around, and it becomes unplayable. So they try to maintain these high frame rates so it looks great and the animation's great, wonderful. So the game can only move as fast as these individual frames, and everything has to be figured out in between. So when you're in a game and you are taking a step and you're jumping from platform to platform, or you're shooting at an enemy, or they 60 times per, well, no, sorry, let's do 30 times per second. It's determining if you've shot at somebody, if you've hit, if you've caused damage, how much damage did you hit, did they damage you, did you jump, did you make the jump, did you actually solve the puzzle, everything that goes from basically moment to moment in the game can drive all of these changes. So at 30 times per second, the game is constantly updating, and we can identify changes in the game or different game states that happen at these different points in time. So from the very beginning, when you turn on the game is constantly asking questions and giving results and doing actions that you perceive as just playing the video game, but it's constantly figuring all of this stuff out in the background, and we can use all of those ideas to drive changes in our music. So here's an example using 2D platformer. We know that the game uses intros, main loops, and endings. And we know that the intros play for 2 bars. It randomly has to choose an intro, plays it for 2 bars, transitions into the main loops, randomly chooses one of those, plays it for 8 bars, randomly chooses another one, and then eventually, when the character loses all of its health, it transitions to the ending cues. So that's generally what we're going to do. And from the point of view of the computer, though, it goes a little bit differently. So when the game starts, the window pops up on your desktop or pops up on your screen, and the character kind of falls onto the level, and you can run left and right and jump and shoot and start playing the game, and the enemies start popping up and the game starts. So when the game starts, at that very first frame, or like probably right before it draws the first image on the screen, the computer says, okay, the game has started. What do I do with my music? What do I do with the music? The game looks at the code and says, okay, there should be 3 intro files. They're going to be located in this particular folder, and we need you to randomly choose one of them and play it. So the computer sees that the files are there. As long as you have, as the composer, as long as you have created the music, named and formatted everything correctly, and bounced those files and put them into a particular folder, then the game takes care of the rest. So it says there's 3 intro files in there, randomly choose one and play it. Computer finds those files, randomly chooses one, and starts playing it. And then it ignores for a period of time while that file is playing. And so at 30 times per second, the computer is constantly saying, okay, is that file done? No. Is that file done? No. Is that file done? And it constantly asks the question over and over again, has that file finished? And once the file, at some point, 30 times per second, after 2 bars of music, the answer becomes yes. That intro file that you were playing is now done. What do I do? And so the game looks at the code and says, okay, intro file is done. It says that there are 3 main loop files. They're named exactly like this, and they're in this folder. Randomly choose one of them and play it. And so the computer goes and looks in the drive and, oh, yep, in this folder, named this, there's this file. All right? Play that, randomly choose one, play it, and keep playing it until the end of the file. So 30 times per second, the computer says, okay, is the file done? No. Is the file done? No. And at the end of those 8 bars, at one particular frame, thousands of frames have gone by at this point, right? Because you got 30 per second. They're constantly going by, but at some point, the answer all of a sudden becomes yes. Hey, that main loop has stopped. What do I do? And it keeps doing this over and over again. It waits till the end of the file. It says, okay, file's done. What's next? And it plays the next one. And it just does it so fast that it seems to be seamless. You don't actually hear it switching from one to the next. And it only works musically because that's the way you composed it, to allow you to transition when it reaches the end of the file. Constantly, the entire time from the beginning of the game, it's also asking another question that says, have I lost all of my health points yet? Have I died? Has the character fallen off the game, off the level? Have I lost a life at this point? And while you are playing the game, the answer is constantly no. No, nope, he's still there. He's still got all his health points. He's still fine. Okay, maybe he's low. Okay, wait, nope, he got some health. He's fine again. Keeps going and going, and until eventually the answer to that question is yes. At some point, you will lose all of your health points, and the game will say, okay, now what do I do? Well, the character falls off. It loses the bazooka goes flying. The character falls into this toxic river down below, and it says, what do I do with the music? Okay, well, the game's over. The character's died. Stop the previous piece of music. Whatever main loop was playing, we don't have any clue where we are, but whatever we were doing, stop that piece of music and immediately switch over to one of the 3 ending cues. And it does this, again, at 30 frames per second, 30 times per second. It's just constantly asking questions. What's happened? What do I do? If you're familiar with computer or code at all, you might have heard the idea of if-then statements. If something happens, then do this thing over here. That's a very, very common, very, very basic idea in a lot of computing. And that's what we basically use. They're commonly known as like hooks or triggers that says, hey, I lost all of my health point. Okay, well, that triggers the ending music to play. Or it's something like, oh, if this thing happens, well, we'll hook this piece of music to it. So when that action happens, we're going to trigger the correct piece of music. A game state isn't really anything except for an idea or that question of, hey, has this thing happened? If this thing happens, then go do this thing over here. It's really just an idea or a question. Intros are game states. Main loops are game states, and endings are game states. They're music. That's what we've done with them. But they're really just concepts or ideas of how the music is going to change. So really common game states that are in a lot of different types of games. Time. How much time do you have left? Super Mario Brothers, classic example of this. As time started running out, the music went to double time. It sped up and says, "Okay, you better hurry up, or time's going to run out." And so we can drive the change, or we can trigger the change based off of how much time is left. Health. Do you have low health? A lot of games, if you get below 10% health, the music changes or the mix gets all weird, or you get like this heartbeat effect or something that says you better go find health. Score. If you get the high score, you get a piece of music. If you have low score, you're like last place, you get a different piece of music. So those are all general ideas of how music might change according to different game states. Whatever the state the game is in at any one time. Am I winning? Am I losing? Do I have full health? Low health? How much danger am I in? How many enemies are around? How much health do the enemies have? Am I winning or am I losing? Do I get first place in this game, or did I take too long to solve this puzzle? All of those things are really just concepts and ideas that can drive changes to our music. The next idea here will be ways to use this concept of game states. And these are two concepts of how our music is actually running in the game itself. Two different approaches to how music works in a game. Also maybe thought of two different dynamic music systems. Two different ways that music could play back in a game. The real answer to all of this is a lot of more modern games use both of these approaches. So they really shouldn't be considered as two completely different approaches that have nothing to do with each other. But our 2D platformer game, our first game of the month, takes a horizontal approach, and our second game, Angry Bots, is going to take more of a vertical approach in playback. So what do I even mean when I talk about horizontal resequencing and vertical layering? I consider them like long terminology for a pretty simple idea overall, or at least maybe one that you might have already experienced or be familiar with, but not ever had a term of how they might actually work in a game. I often consider this ideas that folks that have been working in the games industry have been using for a long time, but only since some of those people actually write textbooks and set up curriculum around it, that they actually have to nail down certain terms, and so they make it sound very important. And it's an important concept overall, but I really just refer to this as horizontal and vertical. You'll hear me say horizontal music system, or vertical arrangement, or vertical instrumentation, or vertical approach to the music, or approach to game music. And when I mention those terms of horizontal or vertical music in a game, let me give you some sort of visualization for this. When I talk about a horizontal music system, I would encourage you to imagine a single track in your DAW where you have multiple regions on that track. Let's say these could be like verse and chorus, or part A, B, C, and D, and just make these even more different here. Let me see what we're doing. All right, so these 4 regions on this track, they in a Logic session or a DAW session, are you supposed to see something on screen? Absolutely. There we go. So on in Logic here, we have 4 regions, and those would represent audio files. And just like a standard DAW session, they would represent audio files somewhere on your hard drive. And they aren't the audio files themselves. They are just kind of windows into those audio files that you can hear. So then you can change or adjust these different regions however you want. But since they are on a single track, you only hear one of them at a time. And as they play and transition from one to the next, the previous file stops playing and the new file starts playing. And you only hear one at a time, right? This is very common in a DAW session. If you had just one track, you would only hear the files that play on that one track. And they don't, I guess you could get a little crossfade between them, but really only one file plays at a time. So this is the same idea as a horizontal music system in a game. Here we go. Horizontal music system, or horizontal resequencing. Individual sections of music that can be shuffled around into any order. So here, this might be, you might think of this as like intro, main loop 1, main loop 2, and ending. These could be representing different music cues. They could represent different game states. As different things change in the game, they'll have music files attached to them. Same sort of thing here. These represent different game states. And intro, action, power-up, low health, and death. Those are common ideas that may happen in an action game. So they represent different game states, different changes in the game world, and of which we have attached different pieces of music. We've hooked different pieces of music to them. Intros, actions, power-ups, low health, death. Intro happens when the game starts, just like 2D platformer. Action happens, okay, so maybe we have an intro cue that plays, and then it switches over to the action cue. The action cue plays, maybe we hear this for most of the gameplay, and then eventually we get a power-up. And that power-up lasts for 30 seconds. We can go, we're infinite life, or we're invincible for the next 30 seconds. We can go around causing all sorts of damage, and we have a 30-second long piece of music that goes right along with it. Once that's done, it jumps back into the action cue, keeps playing with that. And then you get low health. It'll jump over to the low health queue. And the real key here is that only one file plays at a time. The entire mix needs to be in that file. Since it's only one, it needs to be the full stereo mix. So drums, bass, harmony, and melody all need to be captured into one region, or one piece of music, one audio file. And those files need to be able to shuffle and switch and change according to whatever is happening on screen. So just like 2D platformer, you would maintain the same tempo, same time signature, same key. Definitely helps as you jump around between these different pieces of music. So only one is heard at a time, and it can shuffle around into any order that is necessary. Horizontal music, a horizontal musical approach is more often used in what I'll say more straightforward games, where it's a more linear approach to the gameplay. Action games, puzzle games, casual games, kids games. Like puzzle games, kids games are typically more simpler games. If your game is based off of a puzzle, it's a mobile game where it has a very linear approach. You have to get from level 1 to get to level 2 to get to level 3, and you know generally what the player has to do. They have to solve this puzzle that they're either going to win or they're going to lose. They might have to get a certain score. They have to they don't run out of time, and where you have a better idea of the general progression of how the music is supposed to play. A horizontal music system works because it's almost like breadcrumbs, where you are feeding the player the correct piece of music according to whatever they need. You have this kind of bag full of music, and then once they reach that point, you kind of feed them the right piece of music as they go. So even action games, even big, often like real story, narrative, story-driven games, popular games, Uncharted series, the single player of a Call of Duty or a Battlefield or Assassin's Creed or something like that. Even those games can benefit from more of a horizontal music system because it's a linear story and a linear approach. They have to go through a certain path to get through to the next piece of music or the next part of the game. So can be a real common approach overall. You're using multiple themes. Each one of them is fully mixed. Each new theme replaces the one before it, so you're constantly shuffling around. Like when main loop 2 comes in, it replaces main loop 1, and when main loop 1 comes in, it replaces main loop 3, and whatever happens as it jumps from one to the next. So, I said that when thinking about a horizontal music system, to consider it like a single track in your DAW, where everything is horizontally laid out side by side, and you play through the mix or you play through the pieces of music, and one file plays, it stops, the next one starts playing, intro plays, it stops, goes into main loop 3, then it stops, goes into main loop 2, ending is done, so it plays through the end of the music there. When we're talking, however, to compare it against a vertical music system, now we are talking about music that is vertically laid on top of each other, multiple files that are going to play at the same time in a loop. So now our music is vertically stacked on top of each other. Instead of thinking about this as a single track in your DAW, now we are thinking about a multi-track DAW session where individual tracks have groups of instruments that play, and they can fade in and out of the mix and be kind of introduced and taken away at any point that you want. So what this does for us is it gives us one whole piece of music that a new idea can just be faded in and out whenever you need it, whenever you need to. So you can have, typically this is broken into levels of intensity. Maybe action music or battle music, battle level 1, battle level 2, and battle level 3. As the battle continues and gets more difficult and more action-packed, then we're going to introduce more and more layers of music to kind of build or crescendo everything to the peak. And we're basically focused on building intensity and building tension and kind of releasing it back down to create our music soundtrack. So actually, let me take a step back here. One positive part about a horizontal music setup is that it's kind of more straightforward, and you can feed the piece of music as necessary, as I was talking about before, kind of like a breadcrumb trail to lead the player on through the game and through the music. The one of the drawbacks of a horizontal music system is you have to wait for a logical point to transition the music. Meaning that with our intros into our main loops, we have to wait for the entire 2 bars to play through the intros to make our transition into one of the main loops. Then we have to wait all the way through a main loop to make a transition into the next main loop. The only reason this works is, again, because you composed it that way so that it feels like one linear piece of music if played where they are basically butted up next to each other end to end, and it feels like one consistent piece of music. So it's built this way, but we do have to wait to transition from one piece of music to the next. That doesn't always work. Sometimes you want a new piece of music to come immediately in when you want the piece of music to immediately come in when that action happens. Good question here in the chat. How does that apply to power up? You need, when you pick that power up music on, or no, let me say that again. When you pick that power up, the music needs to turn on immediately, and it needs to play for 30 seconds, and then it needs to stop. And you can't wait for whatever piece of music that was playing to end. It's especially now when you're doing 8-bar loops, it's not all that long, but it's still not immediate. And if you're working with loops that are minutes long, then that means that's a long period of time that you have to wait. So the other answer is that you just cut it off. And that's what we do with our ending cues, where we're playing whatever piece of music whatever main loop was playing immediately gets cut off, and it just transitions over into power up. Oh, sorry, transitions over into ending. But and you can use this with the power ups. So whatever music was playing, it just stops and it transitions over into this new piece of music, plays that during the power up, and then stops and then switches back over. Sometimes this works. Going back again to the original Super Mario Brothers, when you get the invincible star, it's kind of bouncing around. You pick that up, the music immediately stops and it goes da 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 da. And when it's over, it just picks back up the music wherever it was. And most of the music in Mario is a form of either a halftime or double time centered around some tempo overall, so that whatever piece of music you bring in may not be perfectly on beat, but at least it's in the same tempo. So sometimes that works. Sometimes you can just cut the previous piece of music off. And it works for our ending cues because we just lost. The game's over. We can just lose control. We can lose control of the music and just cut from one to the next. However, a lot of times that's a bad choice. You don't want to just turn off the previous piece of music. You are not guaranteed that it's in sync, that it's going to play and basically beat match to whatever piece of music was playing before. You don't know where you are in the music. You don't know in what bar or beat you are in to make it a logical transition. I always relate it to, it's kind of like traveling down the highway and not waiting for an exit ramp to exit, right? It's like, okay, I need to get off, and so I'm just going to pull off into the side of the road, off into the grass, and make my own exit. That's probably not a smart idea. Same thing with your music. It's probably not the best idea just to cut it off and go into the next piece of music. It's like a DJ who doesn't match their records and just throws the crossfader from one to the next, and just some new piece of music comes in. Not always the best idea. So the next level of complexity, and that's the basic way that a piece of music will work in a game. The next level of complexity is to actually teach your game to count bars and beats, or teach the computer to count bars and beats, to be able to understand tempo and time signature, and be able to understand where a logical point is to transition in the music. To say, I'm going to wait for a particular beat, or I'm going to wait for the next bar or the next 2 bars before I make a logical transition and move off to my next piece of music. Oh, I'm traveling down the highway. It's probably a smart idea that I wait for the next exit ramp to actually get off. So, and this, like I said, is an extra layer of complexity. It doesn't come straight out of the box. Some programmer somewhere has to teach the computer to count bars and beats, which isn't like completely impossible, because one of the main things your computer is a clock. That clock counts milliseconds. Those milliseconds, so many milliseconds equals a second, so many seconds equals a minute, and so many beats per minute equals the tempo of your music, and then you can start counting bars and beats, right? I mean, that's a horrible oversimplification for everything, but this is why one of the popular tools like Wise and Fmod will talk about audio middleware tools that have this functionality already built in. one of the reasons that these tools are very popular for music and audio for games is it gives you functionality like this, to allow you to have your music switch and change according to the actions that are happening in the game, and then actually make them wait till the correct bar or beat to make sure everything is in sync. So here, a good question in the chat. In Mario, the power-up sounds in a different key and even feels at a different tempo. Maybe it's double time, but it still feels very different. Is there an option for the power-up music, or should we stick to the main key and tempo? Now, there isn't a specific, for 2D platformer, for our projects, there's not a specific piece of music for a power-up. But in a full game, when you have to approach that, it is a creative decision, and it's a discussion that needs to happen with the client about how much do we want to keep everything in the same key and the same tempo. A lot of times, clients will look at you funny when you say that, because they have no idea what you're talking about musically when you say key and tempo. I mean, people kind of understand what the tempo of the music is if it's fast and slow, but understanding beats per minute or double time or half time might be a little bit different. So a lot of times that means you come up with these ideas. Generally, it's safer to maintain the same tempo and the same time signature and the same key, especially if you're switching often like we do in 2D platformer. If you have more time to explore different changes, like key changes and tempo changes, then maybe you can get away with that. And a lot of games use a transition stinger to help you get from a different tempo and a different key into the new piece of music. So when that power-up hits, maybe there's this big, strong impact, and an announcer voice comes in and says, "Overkill," or something like some crazy thing, and there's a power, like an actual charge-up sound, or sometimes they kind of distract you with music, with sound effects and dialogue to get in the way of it. Sometimes it doesn't even matter. Sometimes it's like, all right, I can go cause a whole bunch of havoc, and not even paying attention to the music, so it can kind of blend away in the background, and you can get away with it. There isn't a hard or fast rule that says you better stick in key or stick in tempo or time. And even honestly, for our game projects, you can try it, but you would probably see how much you can get away with before it really becomes annoying. And it often becomes annoying to us as the composers first, before the client and even the general public actually get annoyed with it. It all depends on how real obvious and in your face it is. So the summary of that idea is that with a horizontal music system, there is the possibility that you have to wait for the next piece of music to come in, before wait for a particular bar or beat to keep everything in sync. And sometimes you don't want to wait that long, whether that's just a few beats, or whether that's a few bars away or minutes away. You don't always want to. More often you want to react immediately. And so a vertical music system allows for this a bit easier overall. We said that we think about a vertical music system like a multi-track DAW session with multiple instruments playing across different layers or stems of our music system. And this isn't necessarily divided out into drums, bass, harmony, and melody. It's divided out into tension and intensity, or it's divided out into character or location, something in the game that requires a new game state or a new piece of music or a new change to what is being heard. So a piece of music can play, And if something happens in the game, we can just immediately fade in the new piece of music, and it's going to make sense. It's going to be in key, it's going to be in tempo. Because it was composed that way, it's going to feel like it was supposed to be there. Because it was always there, it was just muted or faded all the way out. So you can fade in a piece of music over time, or you can just mute it on and off, bring it in immediately, and it will make sense. A really good example, I always go back to Mario. Whenever you jump on Yoshi's back in a lot of these games, some bongos come in or congas come in that bongos, a higher percussion overall that adds a new layer to the soundtrack, and it's in key or it's in tempo overall, and it just adds to whatever was playing there. So a vertical music system is splitting out the music into different instruments and applying them to different game states. So ambient, proximity, close, action, break, action, cooldown. Instrumentation will build up and break back down and build back up again to react to whatever is going on in the game. So really it's one ongoing piece of music, but it introduces elements matching whatever the player is doing. So it can immediately fade in those ideas whenever it needs to. Each new layer is faded in, or it can be muted on and off wherever it needs to go. This works really well with what is known as open world games. As games have gotten more advanced over the years, technology has gotten better, the world or the game has gotten bigger, and instead of being based off of individual levels, your character is just dropped into the middle of a world, and they can explore this world in any sort of direction, known as an open world game. This becomes much more of a challenge for the player because earlier I said that the player could basically lay out like breadcrumbs, leave a trail of breadcrumbs through the story. So when they arrive to that part, they have a perfect breadcrumb or a perfect piece of music ready to go. And that works in a linear story where the player starts at level 1. They go from basically point A to point B to point C all the way to the end of the game, point Z. Right? And there's only a lot of the games, even really popular advanced games, still the only way to get through the game is one perfect way, right? One perfect path through the game. But in an open world game, you do not have to travel from A to Z in any sort of linear way. Examples would be like one of the Elder Scrolls games, like Skyrim, very well known for this. A World of Warcraft kind of game. What else is popular? Witcher. So there's all those in the fantasy world, kind of the fantasy side of things. Got Next Life here in the chat. Absolutely. What else? The Rockstar games, Grand Theft Auto and Red Dead Redemption are also open world games. They don't always have to be fantasy games. Basically where you're a character placed in the middle of a world and you can go navigate through that world in any sort of way that you want. So this becomes more of a challenge for a composer because we don't know when you're going to do anything. We don't know what path you're going to take and what direction you're going to head. So more open world games are often based off of location in the world. We don't know when you're going to get to the safe town or when you're going to get to the dangerous dragon's cave. But we know that once you arrive there, we're going to have really dangerous dragon cave music. I don't know when you're going to get to that town, but once you get there, you're going to hear some nice, safe town villager music or whatever it is. So it's based off of location. Wherever you end up in the game world, I know that you can show up there, so I have a piece of music ready. And location is often connected to proximity. It's not only where you are, but how close you are to something will actually drive changes in the music. So if I get close to or enemies are a good example. You may not be close to any particular landmark, but if you're close to a whole bunch of enemies and there's a whole bunch of danger around, then all of a sudden the music picks up and we're going to change. So vertical music system allows you to kind of ride these changes up and down. Another type of game that uses this very well are horror games. Horror games, just like horror movies, are all about building tension up, getting the player sitting on the edge of their seat, and then the monster jumps out, and all hell breaks loose, and the action happens, and it gets all wild and crazy there for a moment until everything kind of calms back down, just to start over again. So all of these different colored blocks here represent different game states, and they in the context of a horror game, these can build up and kind of break back down. It still is using one ongoing loop. Everything is in the same key and same tempo. Everything has to follow a common chord progression so that it all makes sense. The worst thing that can happen in all of this is a whole bunch of dissonance and dissonant pitches and clashing rhythms. I mean, I guess that might work for a horror game, but not necessarily for a fantasy game. But talking about a horror game, using ambient, proximity, close, action, and cooldown. In a horror game, you're wandering around it's a haunted house, or it's an abandoned space station that the aliens have taken over, the monsters have taken over. So an ambient layer would be heard when the player is safe at this moment. Maybe the player may or may not know they're safe, or maybe they don't feel safe, but at this point, there's no enemies around, there's no monster around, they're safe. So they have one layer, and a lot of times this can be really kind of formless, kind of ambient layer. It's a lot of bass and pads and interesting. It's more textural based, is a great kind of foundation to start from. Then you have proximity. Now the monster's out there. Again, maybe the player knows it, maybe they don't. Maybe the monster knows it, maybe they don't. But there's at least in proximity. There's somewhere out there. So now the little bit of percussion comes in, or maybe the low tension in the bass happens. Then there is close. Now, maybe the player knows that the monster's just around the corner and they're hiding and they're ready to either, maybe they're tense and maybe the monster will pass by, or maybe they'll get discovered. Or maybe the monster's crouching, ready to attack the player. The player's completely unaware, but the music still builds and builds, and this is where the peak of the tension happens. Right before the monster jumps out and attacks, the action happens. All of the tension breaks and you come in with a full orchestra and all of the percussion and everything's pounding away and it's loud and strong. The battle is happening, and then a couple of things might happen. Well, two things. You're either going to win this battle or you're going to lose the battle. If you win, you either defeat the monster or maybe you get away and you run away far enough to fight again. But if you lose, well, then it's all over and eventually we'll start the whole process over again. But if you win, then there's a cooldown phase. You can't just drop everything out. You can't, the bottom of the music just kind of falls out and you plummet back to ambient. There's a cooldown phase. You kind of have to step down musically, just like your heartbeat. If your heart rate skyrockets, it doesn't immediately fall back down. You have to breathe a little bit and calm yourself down over time. So the music has to do the same thing. Drums resolve. All of the instruments will resolve back to either a lower layer or maybe like finish and resolve back to the tonic or whatever it is. Everything kind of wraps itself up with a bow before it returns back to that ambient layer, and eventually we'll start the whole process over again. So there's two main approaches to this vertical layering of the music, and basically these are how do you progress through the music. Additive layering is what I just described, where ambient plays And then when you hear proximity, you hear ambient and proximity. When you hear close, you hear ambient, proximity, and close. When you hear action, you hear ambient, proximity, close, and action. Basically, it's adding new layers of music every single time. All of the previous layers are still there. They're still grinding away, but the new layers are added in on top to build up more tension, more power to the mix. And then they are kind of peeled away one layer at a time. So there's only one way in the mix and there's only one way out. It's the positive aspect is that you are always guaranteed that the previous cues will play, meaning that if you add in drums, you don't have to add more drums in later because the previous ones will stay there and will always be playing. The drawback here is that, again, there's only one way in and one way out. There's less combination and variation in these in the mix of these layers, which is the advantage that we get from our other approach of interchanging the different music layers, meaning that you can have multiple pieces of music. Let's go with this example. And you can add a piece of music and subtract any piece of music at any time. So I can fade in 1, and then I can fade in 3, then I can fade in 4, then I can fade out 1, and I can fade in 2, I can fade out 4, fade in out 3, back to 1. And basically there's no set guarantee that any file is going to play. This gives you the most possibilities. This gives you the most variation because at any point, any 1, 2, 3, or all 4 of these are going to play in any sort of combination, and whatever combination you want will always make sense because, again, that's the way you composed it. You composed this as one piece of music that can be split out into individual parts, individual layers or stems that can be interchanged back and forth. Does not rely on one constant bed, so you're not ever guaranteed. That means if you might need to have a little bit of percussion in every single cue because you're never guaranteed that one cue is always going to be there with your percussion. Different ideas like that. Relies on one constant bed but creates multiple different musical combination by mixing any different combinations of tracks. And for our last topic here, we are going to discuss generative music systems as another approach to creating music for a game. And a generative music system has no pre-recorded music. This is where the game is generating the music soundtrack in real time. There is no composer. There is no pre-composed music. The game is given a set of rules by which to generate the music, and then it takes over from there. There is no pre-recorded, set, composed composition that plays back. And this is where most composers throw their hands up and say, oh no, the robots have taken over. They won't need the humans anymore to make music. Skynet is just going to compose all of our soundtracks for us in the future. They're going to be out of a job because the game is just going to do it all for you. And who knows if ever one day that will be the case, but certainly for the time being and pretty much for the foreseeable future, this is very much not the case. Because generative music is some of the oldest music technology in games, but it's still some of the most futuristic, we haven't really even figured it out, technology existing for games. It's because it's really quite difficult. You have to effectively teach the computer to make music. You have to teach it the history and approach of music that humans have taken for thousands of years. Humans learn music either officially through composition and theory classes, or um, or I mean, most people learn about music just through life and growing up over the years. So it's still a very difficult task to teach the computer to make music. It is possible. The computer certainly can, and currently there's technology where the computer can easily generate and create music, but it's not sort of lifelike, or it doesn't sound like any sort of way that a human would compose. It seems very random. So the question here in the chat: where does the sound come from? Where do the instruments come from? What some sort of virtual instrument in the game console? The answer to that is yes. Back in the original Nintendo, there were synthesizers. There were not synths so much as oscillators in the chips on the game console, hardwired into the game console, into the original Nintendo, were 4 basic sound channels. 2 of them were pulse waves, 1 of them was a triangle wave, and 1 of them was a noise channel. And so they would actually generate the sounds in real time. The music was pre-composed, and there were some games that would use some form of generative music, but it was still generated and created in real time. Nowadays, you basically give a computer a sample library, like a contact library. It's not a contact library. It's not using the exact same technology, but it's the same idea. You give the computer a drum kit, a sample drum kit, a kick, snare, and hi-hat, and you say, the rules for this drum pattern are you can use the kick on 1, 2, 3, and 4, but none of them back to back. The snare can be on 2 or 4 or both. The hi-hat can be this 8th note pattern or this 16th note pattern or quarter note pattern or triplet pattern or whatever. Your bass line is going to be this synth bass or this sampled bass line or sampled bass, and it's going to be in this pentatonic scale. The harmony is going to be these instruments, and they're going to play a series of 12 chords, and it can be randomly choose any one of those 12 chords. The melody is going to be this lead instrument, and it's going to be in this key or this scale or in this mode or whatever. And beyond that, the game just randomly chooses notes out of a hat. I mean, it does get more complex than that, certainly. It's not just completely random. There are limitations and guidelines that can happen with the music, but effectively, at some level, it is random. And means it can be different every single time. Or else if it's not different every single time, then it's pre-recorded and it's pre-generated. So there's the drawbacks currently are that it doesn't actually sound like a real human making the music, or it's not to the caliber that a real human can create a full orchestral soundtrack, or even whatever the instrumentation is. So it's not there yet. But it does work. There are some good examples of this working. More mobile games, more popular on mobile platforms or with limited resources. If you don't have, let's say, you don't have the space to record 2 hours of piano music, might as well give the computer a full 88-key piano sample library and feed it MIDI, or just have it generate the music. It's a different approach. Sometimes it works, sometimes it doesn't. There was a popular game somewhat recently called Spore, made by Electronic Arts. It was made by the same folks that did SimCity and The Sims and SimWorld. And the Spore was basically Sim Universe, or you could like simulate alien races. You could create and generate alien races and alien worlds and all this sorts of stuff. So it was pretty interesting overall. The music soundtrack was done by Brian Eno, so it had a very ambient soundtrack. Generative music systems work very well with ambient music because it's formless, or there's less structure, less form to the music, feels a little bit more random, or if it is random, it still kind of works. A more recent game that got a lot of notoriety for its successes and failures in this kind of arena is a game called No Man's Sky, and it was released on PC and consoles, certain game consoles, and they promised a universe of planets and characters and worlds and environments. There were supposedly 15 quadrillion planets in the game universe, and you could visit and almost feels like an infinite amount of game worlds that no other player that ever plays this game will ever experience or visit. And that was true. The game would generate planets and animals and monsters and the flora and fauna of that planet. It would generate it all from algorithms and math, and it was technically pretty impressive. But as a game, it got kind of stale pretty fast because, yes, it was an infinite amount of creatures and characters in the game world, but they're all basically from the same template, and they generally had the same characteristics. You went to an almost infinite amount of worlds, game worlds, but they were all basically the same planet with similar mountains and rock structures and grass and plains and oceans and stuff like that. It was pretty impressive to an extent until it actually got down to the creative gameplay, because there was very little human touch to everything. The human touch came into generating the algorithms and the technology that made everything, but there wasn't individual story and character development and a design that an individual or a team of humans could actually render in a game. It was randomly choosing numbers out of a hat to generate the game world and the gameplay. And while certain elements of it were absolutely amazing, other elements were certainly fall short. So it's kind of like CGI or computer-generated characters in a movie. Movies come out all the time with computer-generated characters, and you watch the movie and you're like, wow, technology is getting pretty good because that looks pretty close, but man, I can still completely tell that that's done by a computer, right? Eventually, it may become indistinguishable to the human eye, but at least for right now, it's really darn close. And what they figured out is the closer that you get to actual reality, there's still something in our human nature that we can identify that it's fake or it's computer driven. Same thing goes with our music. Yeah, man, you can get really close, but to the human ear, we can still identify something that makes it sound different. There's a couple of examples that I provide of videos and websites with generative music examples. This Google WaveNet, what they're doing with Google. Again, this is Google. They're kind of at the extreme cutting edge of computing technology and artificial intelligence and having computers generate voice and art and music, and you go listen to the examples and they're like, yeah, kind of, sort of, but they still feel kind of random overall. So it'll be a while to see if computers, right? They always amaze and they always keep pushing forward. So who knows someday what will actually happen with all of this. But for the time being, it still takes a human composer to actually create interesting music that works well with our perceptions of what music should sound like in a video game. So, interesting technology, good concepts to talk about overall. If you do have any questions, please post them up. I'll be sticking around for a couple of minutes after class to answer any questions that you might have. but we talked about different music systems. We talked about the approach and the use of linear loops or looping music compared to one-shots. The idea of how stingers are used in our games, in our music soundtrack. Then we talked about game states as the concept or idea that drives changes to our music. And then we discussed horizontal and vertical music systems as different compositional approaches to how we might solve problems that in our music to react to how the gameplay happens and or how somebody might play the game. So hopefully that gives you some good insight into the inner workings of a game soundtrack. And we'll wrap it up there, and we'll meet next time and discuss. Next time, we will discuss your first round of music submissions from the 2D Platformer Game Project. So, thank you very much, and I will see you again next round.